In 1492, Columbus saw his compass spin strangely in these waters, a detail that would ripple through centuries. Decades later, 5 Navy bombers vanished without a trace. A legend took hold, claiming there was an oceanic zone where navigation fails and vessels disappear. When scientists finally put Bermuda Triangle myths under the microscope, their findings challenged what we thought we knew. Are the real dangers truly extraordinary, or are they better explained as misunderstandings of weather, traffic, and statistics? The answer begins with the birth of a myth. No official map draws a clear line around the Bermuda Triangle. The boundaries are more rumor than reality, sometimes stretching from the tip of Florida to Bermuda, then down to Puerto Rico, but never fixed on any maritime chart. For centuries, sailors and navigators crossed these waters without agreement on where the supposed danger zone began or ended. The earliest written account comes from Christopher Columbus. His log in 1492 described strange compass readings as his ships moved through the Atlantic. He noted that the needle no longer pointed to the expected direction, and that sparked confusion among his crew. Even as that entry became the first seed of the legend, there was no mention of a triangle and no warning marked on maps. The absence of any formal designation allowed stories to grow unchecked. Over time, the idea of a mysterious zone took hold, shaped more by hearsay than by geography. This spatial uncertainty proved fertile ground for later tales of disappearance and disaster. Boundaries shifted with every new retelling. The myth began not with a line, but with a question. Where does the triangle actually begin? On December 5th, 1945, 5 U.S. Navy Avenger bombers lifted off from Fort Lauderdale for a routine training flight. The weather was mild, and the plan was straightforward. Soon, radio messages grew confused. Compasses malfunctioned, pilots reported disorientation, and communication faded into silence. All 5 aircraft vanished without a trace, along with a rescue plane sent to find them. In a single afternoon, 14 airmen disappeared. The incident, known as Flight 19, captured the public's imagination like nothing before. Newspapers ran headlines about the missing squadron, and speculation raced ahead of facts. Over the following years, more stories surfaced: lost ships, vanished crews, unexplained silence on the radio. By the late 1940s, the idea of a triangle began to crystallize, though the name itself would only gain traction in the decades that followed. The Flight 19 mystery became the reference point for every unexplained loss in the area. It was no longer just a patch of ocean, it was a symbol of the unknown, a place where normal rules seemed to falter. From this moment, the legend of the Bermuda Triangle stepped out of rumor and into the center of popular culture, demanding explanation from science as well as from storytellers. The ocean within the Bermuda Triangle is anything but static. Here, the Gulf Stream acts as a powerful conveyor belt, sweeping northward along the coast of Florida before veering east across the Atlantic. Its surface speeds can reach up to 2.8 meters per second, about 6 miles per hour, fast enough to carry floating debris 100 kilometers in less than a day. This current is not a narrow river, but a vast, shifting flow, sometimes stretching nearly 900 kilometers wide before narrowing as it deepens. Below the surface, countercurrents and swirling eddies add further layers of complexity, creating a tangled network of moving water that rarely rests. When a vessel founders or an aircraft crashes into these waters, the Gulf Stream rarely leaves evidence in one place for long. Debris that might otherwise linger is quickly swept away, sometimes vanishing into the open Atlantic or becoming trapped in one of the region's many eddies. These circular currents, some spanning over 200 kilometers in diameter, can spin off from the main flow several times a year, capturing and transporting objects hundreds of kilometers from their point of origin. In some cases, debris caught in these eddies is carried deep into the Sargasso Sea or deposited on distant shores, making recovery efforts challenging and often fruitless. Beneath the surface, the seafloor drops away with little warning. The Puerto Rico Trench, the deepest point in the Atlantic, lies within the triangle's loosely defined boundaries, plunging to a depth of 8.6 kilometers. Any wreckage sinking here disappears into a world beyond the reach of most search technology, scattered across steep slopes and hidden in deep sediment. The combination of swift currents, vast eddies, and extreme depth means that even large objects can be lost without a trace. For investigators and families alike, this dynamic ocean acts as both a transporter and an eraser, sweeping away physical clues before they can be found. In this environment, the question is not simply what happened, but where any evidence might have gone. Storms in the Bermuda Triangle do not follow a predictable script. Warm ocean waters feed the atmosphere above, creating conditions where thunderstorms can form with little warning. Meteorologists describe this region as a meeting point for weather systems. Cold fronts drifting down from North America collide with moist tropical air moving north from the Caribbean. These encounters can ignite squalls that appear suddenly and sometimes intensify into severe storms within minutes. Pilots and sailors have documented skies turning from calm blue to dense cloud and lightning in less than an hour. For those navigating by sight or simple instruments, these rapid changes can erase familiar landmarks and make orientation difficult even in daylight. Weather volatility is a primary natural factor. Atmospheric instability is only part of the challenge. The Bermuda Triangle sits in a zone where the agonic line, the line where magnetic north and true north align, once passed directly through its waters. In the early 20th century, that alignment meant a compass would point to true north without the need for correction. For navigators trained to account for magnetic variation, unnecessary adjustments could introduce subtle but significant errors. A course plotted with such an adjustment could send a ship or plane off track by dozens of miles over a long journey. This magnetic effect is not unique to the triangle, but its timing and location coincided with the rise of transatlantic shipping and the era of early aviation, amplifying the consequences. Today, the agonic line has shifted westward, and modern navigation relies on GPS and advanced avionics. Yet, historical records show compass confusion was a real hazard in the decades when many disappearances occurred. Combined with the region's volatile atmosphere, this created a uniquely challenging environment. Sudden storms could disorient experienced crews, while small navigational miscalculations multiplied over distance and could lead to missed islands or unplanned entries into open ocean. These natural forces, invisible but powerful, helped shape the reputation of the Bermuda Triangle as a place where certainty could vanish as quickly as the sun behind a wall of cloud. Researchers now view these factors as complex and interacting, not as evidence of mystery. The waters of the so-called Bermuda Triangle are among the busiest in the Atlantic. Every year, thousands of ships and tens of thousands of flights cross this corridor, connecting major ports and airports from Miami to San Juan and Bermuda. With such heavy traffic, incidents sometimes occur: groundings, mechanical failures, even disappearances. But raw numbers alone can be misleading. In the 1970s, researcher Larry Cushy set out to answer a simple question. Was the triangle truly more dangerous or just more traveled? Cush combed through shipping logs, Coast Guard reports, and insurance records, and he compared incident counts not just by location, but by exposure. How many ships and planes actually passed through these waters? The results upended the legend. When Cush adjusted for traffic volume, The Bermuda Triangle's incident rate fell in line with other busy ocean routes. In fact, the region accounted for just 4% of global maritime casualties, despite handling up to 10% of the world's shipping. Aviation losses per flight hour were even lower than in some storm-prone equatorial zones. Later studies by NOAA and the Coast Guard confirmed these findings, showing no statistical anomaly. The apparent mystery, it turned out, was a data illusion. High traffic combined with normal risks produced a normal number of accidents, not an excess. When researchers treated the triangle as a math problem rather than a ghost story, the numbers spoke for themselves. The true outlier was not danger, but reputation. A reputation built on misunderstanding how statistics work in a crowded sea. Official agencies have weighed the evidence with a steady hand. NOAA reviewed decades of incident reports, shipping records, and flight data before issuing its assessment. In its 2010 report, NOAA stated plainly, there is no evidence that mysterious disappearances happen more often in the Bermuda Triangle than in any other well-traveled part of the ocean. The agency pointed to the region's heavy maritime and aviation traffic, emphasizing that the number of accidents aligns with what would be expected for such a busy corridor. The United States Coast Guard, responsible for search and rescue across American waters, takes a similar stance. Their public statements reflect a consistent position. No unique hazards, no special warnings, and no recognition of the area as unusually dangerous. When maritime insurers and global shipping surveys ranked the world's most perilous waters in 2013, the Bermuda Triangle did not make the list. Instead, regions like the South China Sea and the North Atlantic's graveyard of the Atlantic stood out for higher rates of loss. These comparative studies reinforce what the data shows. The so-called triangle is not an outlier. For every incident, there are thousands of safe crossings, and the risk per voyage matches other high-traffic regions. With these findings, the focus shifts from the idea of a supernatural hotspot to the realities of ocean travel, complex, sometimes hazardous, but not uniquely so in these waters. These institutional conclusions prepare the ground for a closer look at the scientific hypotheses that have been tested to explain the incidents that do occur. Laboratory tanks filled with water and methane bubbles have offered a striking demonstration. When researchers released large amounts of gas beneath a scale model ship, the vessel lost buoyancy and sank. The physics are straightforward. As methane rises through the water, it forms a frothy mixture that can no longer support the weight of a ship. Similar events have been documented off the coast of Norway, where explosive methane releases left craters half a mile wide and 150 meters deep. The geological record tells a different story for the Bermuda Triangle. According to the U.S. Geological Survey, there is no evidence of any significant methane release in this region for the past 15,000 years. Methane hydrate deposits exist, particularly along the Blake Ridge, but they remain stable. Without recent eruptions, the bubble hypothesis cannot account for modern disappearances. Attention then turns to the sea itself. Oceanographers have modeled how converging storms in the triangle can create rogue waves, giant walls of water reaching up to 30 meters high. These waves are not common, but they are possible, especially where powerful weather systems collide. In laboratory tests, model ships subjected to these conditions have been snapped in half within seconds. Real-world data supports the plausibility. Satellite altimetry and wave buoy records show that the Gulf Stream's energy can amplify wave heights during storm events, increasing the risk to even large vessels. Yet rogue waves are rare and tend to occur alongside severe weather, limiting their explanatory reach. They remain a plausible answer for some cases, but not for all. human factors remain a constant thread. Navigational error, misjudged weather, and the pressure of decision-making in rapidly changing conditions have been identified in many investigations. Pilots and captains have faced sudden storms and shifting currents, and in earlier decades, misleading compass readings. Oceanographer Simon Boxall and others argue that most disappearances can be traced to the intersection of complex natural forces and human limitation. While no single theory explains every incident, the weight of scientific evidence points to a combination of environmental hazards and human error, rather than extraordinary or supernatural causes. In the 1970s, a single book turned the Bermuda Triangle from a maritime curiosity into a household name. Its author, a linguist with a talent for storytelling, wove together decades of disappearances into a narrative that suggested something extraordinary was at work in these waters. The book became a bestseller, selling millions of copies and inspiring a wave of television specials, magazine features, and radio programs. Headlines labeled the area the Devil's Triangle, and each new story seemed to confirm the region's reputation for danger and mystery. Behind the scenes, selective reporting was quietly shaping public perception. Incidents that fit the pattern, vanished ships, lost aircraft, missing crews, were given front-page treatment. Other stories, where explanations surfaced or vessels were later found, rarely made the news. The absence of follow-up reports left gaps, and the imagination was quick to fill them. Even routine accidents that occurred inside the loosely defined triangle were often framed as part of a larger, unsolved puzzle. The media's fascination created a feedback loop. Each retelling amplified the sense of enigma, while statistical context and mundane explanations faded into the background. Sensational framing became the norm. Stories referenced ancient civilizations, hinted at underwater ruins, or speculated about electromagnetic forces. The Atlantis narrative, revived by popular culture, found fertile ground. The idea that a lost city or mysterious energy source might lie beneath the waves provided a dramatic hook, even as scientists dismissed those theories as unsupported. As the legend grew, it became self-sustaining. New incidents, no matter how ordinary in cause, were quickly woven into the mythos. The Bermuda Triangle was no longer just a region on a map. It became a story, retold with each headline and broadcast. In this way, selective reporting and media amplification did not simply reflect the legend, they fueled it, ensuring its persistence long after scientific studies had offered less sensational answers. Today, hundreds of ships and planes cross these waters every week. They are no more likely to vanish than anywhere else on Earth. Yet myths persist, fueled by selective memory and media repetition. Real risk lies not in invisible forces, but in misunderstanding the ordinary. In an age crowded with information, skepticism remains our surest compass. What we choose to question shapes the mysteries we inherit. Thanks for watching.